Hello friends. So, welcome to the third week of the course, and previous week we started discussing about the quantitative estimation of the wastewater, and this week we will focus on the quality of the wastewater. So, how the wastewater is characterized, how we ascertain certain wastewater is very bad or poor or okay, or how we basically qualitatively characterize a certain type of water or say wastewater. So, for the purpose, we all understand that just by looking at the water it is very difficult to tell how contaminated is or how polluted is. There are a variety of contaminants, or there are several type of pollution which does not impart any physical attributes. So, it will be very difficult to see if you have a let us say water bottle and I dissolve certain amount of salt in it, probably by seeing it you will not be able to tell it, or that way if I dissolve certain say metal or colorless metal or salt or organic contaminants, just by seeing it, by touching it, it is very difficult to tell. So, since just the physical appearance of the water may not be sufficient to characterize it or may not be sufficient to distinguish about its quality, it becomes essential to sort of fix a certain set of parameters based on which the water or wastewater could be characterized. So, we will discuss these parameters one by one in this week. To begin with, there are variety of quality parameters. Okay. There are certain physical parameters, chemical parameters, biological parameters. So, we can club them into the different classes as well possibly. Okay. And otherwise if you like see a list, so there are several parameters based on which the quality of certain water or wastewater could be characterized. The list is not limited because we are having emerging contaminants. So, that way we can add more and more parameters for characterizing. There are certain things which earlier was not considered as a let us say contaminant or a pollutant, but nowadays those are being perceived as a contaminant. So, for ascertaining a good quality of water or ascertaining a treated reusable quality of wastewater, we need to check those parameters as well. Okay. And that way it becomes a sort of endless list of the quality parameters. We will discuss certain more prominent or more important or more common parameters which are typically used for assigning the quality or characterizing the particular specific type of water or wastewater. Okay. There are few very popular or well known stuffs like we have pH, temperature, color. Okay. Everyone almost knows it. Okay. What pH is, what temperature is, what color is. Then there could be the turbidity, there could be conductivity, the level of dissolved oxygen in it, then the biological oxygen demand, or few people say it biochemical oxygen demand. So, that is typically known as BOD. It is a carbonaceous BOD or nitrogenous BOD, means it is out of carbonic organic compounds or out of nitrogenous compounds. Then chemical oxygen demand, that is COD. There is acidity, alkalinity, hardness. These are not that relevant for wastewater, though more relevant for water quality. Okay. There are variety of solids, the total solids, suspended solids, dissolved solids, fixed or volatile solids. So, a range of these such parameters. There are nutrients, the more common one are nitrogen and phosphorus. There are metals, again an endless list of metals. Okay. Iron, aluminum, arsenic, chromium, zinc, nickel, cobalt, silver, lead. So, there are many more. And so, there are then some biological impurities. So, fecal coliform, okay, or those kind of stuff. We can go more in more details in the form of bacteria, protozoa, virus, what kind of biological impurities the water has, and again there are quite a lot more, okay, which these days we have the pharmaceuticals, we have the disinfection byproducts, we have the chlorinated organic compounds, we have so there are personal care products, pharma products, industrial pollutants, dyes. So, a lot more parameters are coming in. Okay. The one that we see here, most of them are the general parameters that are the most essential or the most basic one, which are typically first analyzed in order to assign the or in order to characterize a certain type of water. Okay. And then there is a scope for further and further and further detailed investigation if there is a need for that. Okay. So, we will see some of these parameters or the major these parameters how they affect. To begin with, pH is one of the most common. Okay. Most of the people know what pH is. Okay. Natural value is 7, less than that is considered acidic, more than that is considered alkaline. If we talk about the water sources, the natural water sources typically have a pH in ranging from 6.5 to 8 in most cases. Okay. However, in extreme cases like if it is coming from acidic rock or those kind of things, so it could be as low as around 4.5, or particularly in alkaline conditions or those kind of thing where it is coming, let us say from lime and those zones, it could be as high as 10, okay, or could be over 10 also in certain cases. For wastewater, again it depends on source of its generation. Okay. The different sources, the domestic wastewater typically does not have too high or too low a pH, it is typically in the range of again 6.5 to 8 only. However, depending on the other sources like some industrial effluents could have very low pH, okay, some could have very high pH. Okay. So, again it will vary depending on its source of the generation. The pH is important because extreme pH may adversely affect the aquatic ecology in surface water bodies. Okay. We know that our aquatic ecosystems will get completely destroyed if pH changes abruptly. Okay. The particularly like for say fishes, so fisheries the sort of like preferable pH range is 6.5 to 8.5, they can tolerate up to say 5 or 8, but extremely acidic or extremely alkaline pH conditions fisheries will not be able to survive. So, are about the various other aquatic organisms, aquatic plants. So, the importance of the pH, although it is a very common parameter, but it is a very important quality parameter which gives an idea about the sort of acidic or alkaline nature of the water or say wastewater. Okay. The measurement are pretty simple, there are pH electrodes, okay, which typically will give you instantaneous pH value. Okay. So, you just insert the electrode into the water and your meter will read you and tell you what is the pH. We need to calibrate it often, and the calibration could be 2-point calibration or 3-point calibration depending on the range we are looking for. If we are trying to work on acidic range, we can have a 2-point calibration between 7 and 4. If we are working on a basic range, we can have 2-point calibration between 7 and 11 or 9. If we are working on a wider range, we can have a 3-point calibration 7, 4 and 9 or 11 that way. The other parameter is temperature. So, temperature is again a pretty easy to measure and monitor, but have very severe effects. Okay. We have simple thermometers which can, or these kind of monitors which can basically just tell the value, tell the temperature. Okay. There are 3 different scales, Kelvin, Fahrenheit and Celsius. So, there is possibility of interchanging between the scales. These are the common stuff that everyone knows though. The effect of temperature, or more particularly the change in temperature, is very critical in living organisms. Okay. Like for our body, we know that we can survive only till a certain range of temperature. For purpose of drinking water, we cannot drink, let us say, water which is boiling. Okay, it is very difficult to drink that water. It is going to do a lot of damage in our internal abdominal systems. So, warm water or that kind of thing can be sort of consumed, but again it depends not only on us, for different living organisms it could have various variable effects. The aquatic population can withstand only a tolerable limit of temperature, which varies for species to species. So, certain species have a higher tolerability, okay. Certain species cannot tolerate that high a temperature. We know that depending on the climates of the different continents, we get different kind of species proliferating in terms of not only the animal species, even the plant species as well. Okay. So, you see in the colder climates you will have different type of trees or herbs or plants. You bring them to a warm climate, they will not survive. Similarly, the warm climate plants, trees, herbs will not survive in the colder climate. Same is for animals over here, animals or any other such population, and even in the microorganisms. Okay. So, we have mesophilic range of microorganisms or bacteria which can survive moderate temperature range of say 10-15 degrees Celsius to 35-40 degrees Celsius, okay, optimum being around 30-35. The thermophilics, they can survive up to 70-80 degrees Celsius, okay, their optimum range would be 50 plus for working. So, there are different range in which the different species prefer to survive and prefer to work. Okay. There are some key constituents of water or pollutants present in the water which changes form based on the temperature. Okay. We have for say you have ammonium ion, it can actually evaporate the system if you increase the temperature. There are volatile acids which will escape from the system. So, the constituents of water or basically the pollutant dissolved when it can also change the form based on the temperature to temperature. The rate of most of the biochemical reactions are also a factor of temperature. This is very important for the wastewater management aspect, because wastewater management wastewater treatment, particularly when we will in like further lectures we will see the treatment and sort of recycling of wastewater. So, we rely a lot on biochemical processes, and this rate of the biochemical reactions depends on the temperature. So, an optimum temperature maintenance becomes essential, particularly in those systems, and for water also. So, if an industry is putting a, let us say there is a thermal industry and it is putting a lot of heated water into a pond or into a system, into a lake, the entire water may get hot. So, you will not going to get the expected natural flora and fauna in that lake because of the temperature issues. Okay. So, those kind of issues and those kind of problems can arise due to the temperature. So, temperature, although very common, very simple to measure, very simple to monitor, but plays a very important role in the characterization of the effluent or wastewater. Then comes another quality parameter which is color. Okay. Now, color is important from the standpoint of aesthetics, okay, because if certain water looks colored, okay, people will make a perception that this water is not good. Okay. A industry is, let us say letting flow a colored water, people will say, oh, this water is very contaminated, it has something in it, right. So, color may or may not be safe. Okay, it is not necessarily that color is always not safe. At the same point, it is not necessary that color is always safe, it may not be safe also, because color may be from the may arise from variety of toxic constituents as well, but may arise from simple algal or humic substances which are not that harmful in a way. Okay. So, variety of organic substances, we consume lot of color in our food. Okay. So, color as in is not a harmful thing. Okay. But when it is in the water, if certain water is colored and if we are offered to drink that water, no one is probably going to drink that water. Okay. Even though water may practically be very safe. Okay. If we are offered a colored say drink, okay, we have, let us say all of us or majority of us drink Coke, okay, it is a very black color thing. Okay. We drink tea, it has a certain color. Okay. We drink lot of shakes, okay, in a variety of colors. We will have a strawberry shake, we will have a, means some will be pink, some will be purple, some will be blue. So, we have a variety of shakes, sherbets, and we are very happy to drink that. But if you ask for a water and I give you a water of, let us say, pink color or water of a reddish or yellowish color, you will probably not take that for drinking purpose. So, it may not be unsafe, the color actually may not be unsafe, but because of its aesthetic points of view, people perceive it not to be a good quality of water. Okay. So, these kind of practical problems arises. Okay. Now, the color are typically of two types, one is apparent color and one is true color. So, the apparent color is caused by the suspended matters. So, something which is colored in nature, and if it is suspended in the water, your water will also look colored. But it is not the color of water, it is actually the color of those particles which are suspended in the water, and if we let those particles settle somehow, okay, if we remove those particles. So, if we filter that water, those particles are removed, or if we let those particles settle down the bottom. So, the water is actually, because water does not have any color, the color was because of those suspended particles. So, water becomes colorless, okay, or comes in its natural state. So, this kind of color are called apparent color, because it is not the color of water itself, it is color of the additional item impurity present in the water which can easily be removed. So, these are called apparent color. Then there are true colors which are due to dissolved or colloidal particles. Okay. So, organic extracts, vegetables and those kind of things. Now, these, because they are in the dissolved state, so even if you filter, it is not going to get removed, even if you let it remain for a large period of time, nothing is going to settle, it is already in the dissolved state. So, the color will remain with the water. So, that becomes the color of water, although it may be because of certain things dissolved in it, but essentially it is a color of that solution, okay, and that is why it is called true color. So, true color cannot be removed simply by keeping it or simply by filtering it, while apparent color can be removed if we tend to filter that water, or if we tend to settle the suspended particles which are imparting that apparent color to the water. Okay. So, that is what is color. Now, for quantification purpose, because as we say that we earlier discussed the temperature and pH, they are fairly easy to estimate. You have just meters and then you put down, it will tell you the pH value between 0 to 14, you put down the your thermometer or temperature probe, it will quickly tell you what is the temperature in whatsoever unit. The color measurement is have various or different scales. So, previously or like earlier, the color was measured using the standard color solution or dilution methods. Okay. So, standard color solution method is basically we prepare a solution of 1 milligram per liter of platinum and 0.5 milligram per liter of cobalt. So, these two are taken and dissolved in pure colorless water, and that solution is taken as the standard 1 unit of color. Okay. So, we have one scale prepared which is called platinum cobalt scale of color. Okay. So, we take that platinum salt and cobalt salt as recommended and we dissolve it, whatsoever color produced out of this is called standard 1 unit of color. Okay. So, that is standard color solution preparation, and then for measurement purpose we compare the. So, for say let us say if this is my solution, okay, which is having some sort of color in it, okay. Let us say put a very light kind of color over here. Now, if my actual sample is having much darker color than this, okay, is let us say having very dark color something, or can have let us say any color that way, okay. So, if my actual solution is something like this, now how I measure the color on this platinum cobalt scale is I start diluting this sample. So, I will prepare different dilutions, I will take let us say 1 ml of this and add 9 ml of water. So, 1 ml of this solution plus 9 ml of water, that gives me 10 times dilution, okay. And then whatever color is come, I will again compare it with it. If this is still darker, I will again go for another round of dilution. So, by I will keep on diluting it until the color becomes equal to this. Okay. So, I will keep on diluting it until the color become equals to this, and the number of dilutions gives me the sort of a unit of color on platinum cobalt scale. If I have diluted it, let us say I got the exact color after 2500 times dilution. So, I will say that the color of the solution is 2500 times on platinum cobalt scale, standard platinum cobalt scale. A similar approach is adopted in your multiple dilution method or dilution multiple method, where it is measured by the successive dilution until the solution turns completely color free, okay, or the color is no longer detectable comparing with the distilled water. So, here we have a standard solution of platinum cobalt scale and we are diluting it and comparing it with that standard solution. Now, here we have it could be other way also, like if the color is less than this, we can dilute the standard cobalt solution and see we can bring it in the fractional form as well. So, whatever could be the range of the color, here we have to dilute the sample steadily and progressively until it turns colorless completely. So, if a solution let us say which is too dark over here, we diluted it 100 times, it become lesser dark, we diluted it further 100 times, it become very less dark, we diluted it another say 10 times, it become very minute, and we diluted it another 4 times, it becomes colorless. So, total dilution if we see 100x into 100 into 10 into 4, okay. So, this becomes 10,000, 1 lakh, 4 lakh. So, 4 lakh dilution. So, 4 lakh x is the color based on this method that way. However, these are the crude methods, okay, the approximation techniques which were earlier used. Nowadays, the color is typically measured by the spectrophotometric method. So, the spectrophotometers are used for measurement of color, monitoring of color, and generally the color value is reported as adsorbance value which are obtained through a spectrophotometer at a particular wavelength. Okay. So, spectrophotometer, the concept is fairly simple. You have a cell, monochromatic light is passed through. So, let us say the value is the wavelength of this light is say for say 400 nanometer. Okay. So, if I pass this light through 400 nanometer, there would be some light based on how much is the color in the solution, some light will be adsorbed, there is simple photo principle. So, some light will be adsorbed, and based on that intensity of light, incident light and intensity of adsorbed light, will get the certain adsorbance value, say if that adsorbance is 0.6 for say. So, then the color will be reported as lambda that adsorbance at lambda is equal to 400 nanometer is equal to 0.6. So, that is become the color of that solution. The thing here is that this adsorbance value will depend on the wavelength. So, if we change the wavelength, the adsorbance value changes. So, at which wavelength the adsorption has been taken has been recorded is of very high importance. Okay. Normally, if we scan the spectrum of say, let us clear it here little, then I can explain. So, if spectrum of one of the okay, right. So, if we see the absorbance of one particular solution at different wavelength at different lambda value. So, say here lambda is 200 nanometers to 1000 nanometers, okay, or 1100 nanometers. So, depending on the amount present or constituent present which is absorbing the light, we can get adsorbance spectra of let us say this type, or let us say adsorption spectra of this type, or an adsorption spectra of this type where there is just one peak, or of one of this type. So, it could be any particular type of adsorption spectra. Now, if you see you just pick any one of this, let us say I am picking let us use one in the different color. So, it is more prominent that way. So, let us say I got an adsorption spectra of this type. So, if for this I take a lambda value of 350 nanometer, I get a adsorption value of say 0.7, say this is 1. Okay. So, I get an adsorption value of 0.7. If I take say what 450 nanometer, I get adsorption value of around 1. If I say take 800 nanometers, I get an adsorption value of 0.2. So, for same solution at different wavelengths I am getting different adsorption values. So, until unless I mention this particular wavelength, it becomes very difficult to identify, it becomes very difficult to know what means later on it will be not possible for anyone to realize at what adsorption at what wavelength this adsorption value is. And conventionally, if we want to report a color, we should choose the wavelength at which the adsorption is maximum. So, for say in this profile that you see here, at lambda is equal to 450 nanometer, as we said, the adsorption is close to 1. So, we can say that the color of this at lambda max is equal to 450 nanometer is 0.1. So, that becomes the color of the solution or reported color for that sample. So, that is how the color can be monitored. Okay. And these are spectrophotometers are simple devices, okay, which works on Beer-Lambert law principle. We will discuss more detail of this maybe on a later class or later session. So, for now this is how typically the color can be monitored. So, we will end this session here, and we will continue discussing rest of the water quality parameters in next session. Thank you.